The Semantic software offers a wide choice of programming languages that support you in the implementation phase of a plant's life cycle. The basic package includes the ladder, FBD and STL languages. The options available include the programming languages S7-Graph and S7-SCL. Each of these languages is in compliance with the IEC 61131-3 standard and is based on a specific language concept. Whereas programming with STL is hardware-oriented based on statement lists, with ladder, FBD and S7-Graph, it is possible to interconnect graphical elements. S7-SCL is a programming language that is similar in syntax to the easy-to-use high-level language Pascal. From these various languages, therefore, it is possible to select the language most suitable for each task to be mastered in an automation plant, and thus keep time and costs down to a minimum. In principle, all automation tasks can be solved with ladder, FBD and STL. However, they are best suited for controlled tasks. S7-Graph, the graphics programming language, is a great help in creating sequences. Thanks to the higher language constructs supplied with it, S7-SCL is suitable for calculations and data management algorithms. All partial solutions implemented in these languages are compiled in Step 7 blocks. This makes it possible to combine all the partial solutions. By employing these three languages appropriately, you can significantly reduce the implementation time. Taking a simple example, we will show you how you can combine blocks created with S7-SCL with blocks created in the basic languages. What we have to do now is realize a data management algorithm. Using the S7-SCL editor, the functionality is implemented in so-called S7-SCL sources. Here you can use function calls to access existing user blocks, the block library supplied, and system blocks that are already available. Due to the universal database integrated in Step 7, it is possible to have read and write access at any time from the S7-SCL program to the entire tag management of the CPU. This can be done both with absolute addressing and symbolically using the symbol table. Once the algorithm has been implemented in one or more S7-SCL sources, the built-in S7-SCL compiler now generates one or more Step 7 blocks. In this way, a control program written in one of the basic languages can implement the following call hierarchy, for example. The algorithm implemented in FB2 can thus be used repeatedly and its behavior influenced by transferring the relevant parameters. By combining blocks that fulfill specific functions in a precise way, you can greatly reduce the development time. Now you can see why S7-SCL is predestined for complex tasks in the field of data processing. In a sample case, data is to be copied from a source array into a temporary single variable. Each element of the source array consists of a user-defined structure that includes one real, one word, and one string data type. In STL, such a task would require one block call and an index calculation via a memory word. With S7-SCL, you can realize this task with just one line, because S7-SCL has an index operator and an assignment operator. So by using the assignment operator, you can copy complete structures with just one statement. Especially in the case of arrays, you often have to run iterations in order to find, read out, or manipulate a specific element. In STL, only the loop command, which also needs code lines in addition, is available for this. S7-SCL, on the other hand, provides multiple loop constructs. With the for loop, for example, you can set the start and end index of the run, as well as the step size in one line of code. Even loops in which the number of steps is not known during implementation can be realized in just one line with the while and the repeat until loops. So with S7-SCL, it is easier and clearer to create program code, especially for data management tasks. This minimizes a great source of errors and therefore also costs.